Good afternoon, good evening, good morning, wherever you are on this planet, and welcome to our SETI Live. My name is Franck Marchis. I'm a researcher at the SETI Institute, director of citizen science and chief science officer at Unistellar. So today we are going to talk about something I've been waiting for weeks and months, in fact. We're going to talk about the future of alien civilization and the fact that we often assume that civilization will grow endlessly, build gigantic spaceship or structures around the stars, and be visible. But in fact, people, scientists like us at the SETI Institute and elsewhere, have been thinking, what if civilization don't have this type of future? Is there any other type of future for a civilization? Something maybe less visible, less noisy for SETI. And to discuss that, ask Jacob, Haqq-Misra. Hello, Jacob. How are you?
Doing well. Thanks for having me, Frank.
To join us. So Jacob is a researcher at the Blue Marble Space Institute of Science, and he published recently an interesting paper on this topic, where he and his team describe 10 different plausible future for Earth's technosphere. And what is a technosphere? We're going to ask later on, and what he will tell us about the search for extraterrestrial intelligence. So, Jacob, before we go through the nitty gritty details of your paper, so first of all, where you're calling us from?
I'm in Delaware, kind of right in the middle of the Delmarva Peninsula.
Okay, and so you are in Delaware, but I can see from the papers you have been publishing. I mean, we have been working on SETI, on planetary ability, for more than 2 decades now, or something like that. So you describe in your paper 10 scenarios, 10 potential future for civilization. So which one will you choose for yourself?
Yeah, that's a hard question. I thought about it. Um, None of these are perfect futures. There's no utopia. I don't want to live in S1. Big Brother is watching you. I don't want Big Brother watching me. But there's others that are more optimistic, others that are more pessimistic. And it depends who I am in the future. Am I one of the elites who gets to sort of reap the benefits of everything, or am I one of the laboring masses? There's a couple of scenarios where you might prefer to be one more than the other. Um, there's some where we've kind of fused technology with nature in harmonious ways, but there was a collapse that happened before that, so it's kind of an optimistic end, but not the best trajectory to get there. So it's hard to say. I mean, it's definitely there's pluses and minuses to all of them.
Yeah, I can. I was thinking about that while reading your paper as well. Which one I want. None of them are perfect, but maybe some good. Some of them for which at least nature, our biosphere, is preserved, which is I
That's
think
right.
the most important.
Yeah.
Okay, let's go through the paper. I'm hoping that people are watching us from a lot of places around the world. Let me say hi to some of them from Sweden, from India, from New Mexico, from Arizona, from Illinois, from the Bayou. Hello, Ron. From Ireland. Welcome. We are talking about the future of civilization, different type of future for civilization with Jacob. And let's go straight to the definition of a technosphere. So you talk about technosphere in your paper. This is the first of a long series of papers, so people will hear about that in the future. Can you explain to us what is in technosphere and
Yeah,
why is it
absolutely.
important?
I mean, a technosphere, we use the word to kind of compare or juxtapose with the concept of a biosphere. So the biosphere is the sort of sum total of all the effects of Earth's biology, the biomass and its effects on other parts of the planet. And so the same concept applies for the technosphere. So you can even think of the techno mass. What's the mass of our technology and our infrastructure, everything from computers to concrete on Earth? And then how does that interact with our atmosphere, our soil, our rivers, all the aspects of the Earth system. So sort of Earth with technology is this a biosphere and a technosphere that's sort of a more recent development than the biosphere.
So we are building a technosphere now. We have, in fact, a technosphere, but we're also growing the technosphere by exploring other worlds.
That's right. The technosphere, in fact, expands beyond the biosphere today. We have technology on Mars. You can argue if there's life on Mars or not, but we haven't really found it yet. And then there's technology further than Mars. Not a lot of it, but some. We've sent orbiters and rovers and probes all over the place, and a couple outside the solar system. So Earth's technosphere has actually spread farther than our biosphere has at this point.
Good. All right, so we talk about different scenarios at the beginning of this conversation. So your team developed 10 different future for Earth technosphere. And we're not going to go through the 10 of them, unfortunately, because it will take a bit more time than 30 minutes. But can you give us some example of the one that you think are the most iconic or people will understand?
Sure, I can. And you know what I'll tell you, if you're listening and you find this interesting, you can go to futures.bmsis.org, and we have a website where we just kind of simply present the 10 with descriptions and some graphics, and so you can dive deeper into all 10 of these if this is fun to you. But I'd say, yeah, there's a few iconic. So I mentioned Big Brother is watching you, and a lot of people have dismal views of the future. Depends on a lot of things. There's a war that happened recently. Do you like the president or not? I mean, there's nothing special about our time now and people thinking about the future in sort of a negative way. And so Big Brother is watching you. We picked names for all the scenarios that are designed to automatically kind of evoke some sort of feelings and metaphor that you're familiar with. So obviously that's a reference to George Orwell's novel. It's not to say that the scenario plays out in the same way as 1984, but more just this is a scenario in which there's kind of a global dictator and a large surveillance state. You're either sort of part of this one-party global government system or maybe part of the resistance. There's you can see elements like that. So I won't get into too many more of the details. Other than our goal was to kind of link these things to the technosphere, which we could get into later. But then I'll talk about two other iconic ones that seem to be sort of popular when I present people with these. So one is S7 restoration, and I think I mentioned this a little bit earlier too. You have to figure out how do you solve problems like climate change and sustainable development and population growth and all of these scenarios. And so this is one where there was growth followed by collapse. But in the aftermath of the collapse, we retain some of the technology and we kind of grow our civilizational ethics, and the population remains much lower, but we don't turn into the Amish or something like that. It doesn't become the Stone Age. We still retain some technology and learn to use it in a harmonious way with the rest of the biosphere. And so you end up with a sustainable equilibrium in which we do have technology. We even have some moderately advanced technology. But we had to kind of go through collapse to get there, but kind of having learned our lesson. And then the other one I think that's popular is transhumanism. And this is one where humanity spreads through the solar system. There's sort of advanced nano engineering of both biology to transform oneself, as well as planets where Mars has been terraformed and Venus is being terraformed. And there's even this idea of we're now exploring our cosmic consciousness in various ways, from introspective exploration to outward, a new era of even SETI in that scenario, where they've constructed a Medi beacon to try to find life elsewhere, but perhaps motivated for different reasons than we might build a Medi beacon today. So I'd say those are some of the fun ones that definitely have different technosignatures from the technospheres in each of those cases.
All right, and so these are models, or those are scenarios to go?
It's a great question. Yeah, these are scenarios. I'll just say, as briefly as I can, these are methods from the field of futures studies, and it's futures studies because you can't predict the future for human systems, complex systems, things like evolution of technology. It's impossible. So what you can do, and what we have done, is you project multiple futures, different possibilities, none of which might be the actual future. We don't put likelihoods on them, but they kind of bracket the possibility space and stretch our imagination to places we might not have taken it otherwise. And we do this in a very systematic way, drawing on methods that are in this field of future studies. And you can read the paper. I won't describe them right now unless someone's interested in them. But what I'll say is that it's widely used in many fields, from military strategic planning to thinking about who might invade who. Marketing wants to do this for thinking about product development and people who might be interested in your services. Shell Oil Company was actually a pioneer of some of these methods and thinking about how changes in global geopolitics would influence a large energy company's strategies. So these methods have been tried and true and pioneered in many places. What we have done is we've gone on a much longer time scale. Probably many people are familiar with climate change predictions from the Intergovernmental Panel on Climate Change. Goes out to about 200 years. So we go a bit further than that to 1,000 years. And we are describing more than just how the climate changes, but really we're interested in what is, the research question is, what does the technosphere look like in different scenarios of Earth's future? And so the one thing I'll add to just get to the heart of your question is how do you do that? When you've got sort of a generic description, our basic assumption is that technology emerges in response and co-evolving with basic human needs. You don't build a thing just to build a thing. There's always a reason. It could be because it's beautiful or it feeds people, something, so the basic human needs draws again on other scholarly work that exists. So we didn't invent that. But it gives us some sort of a basis for imagining future technospheres, because each of these worlds, each of these scenarios have different basic human needs that either have to be satisfied or not satisfied. And you can then think of how those things are linked to technology in each of those cases.
Thank you. Let me say hi to a few viewers. I recognize some names. So we have people from Utah, from Sonoma County, from San Francisco, from Venus. That's probably not really the case. Boston, Massachusetts, from Disco Ball. I'm not sure this is a real city, guys. Come on. Austin, Texas. Yes, we are talking about the future of civilization, our technosphere. And let's talk about Kardashev, because frankly, Kardashev ate something. So Kardashev is from something from the 70s or the 60s, right?
That's right.
And you challenging Kardashev, basically, this idea that a civilization will grow exponentially, and this growth is something inevitable. So can you tell us a bit what is Kardashev, the scales, and what you modeling, basically, how your work has been challenging it?
Sure. Yeah, we do challenge Kardashev, but I mean, this is not to diminish Kardashev's contribution. Obviously, this has been kind of a very fundamental part of the SETI discourse, and it has, certainly been good in terms of driving the conversation forward. But, Kardashev was a SETI scientist, radio astronomer, who proposed this concept of, how a civilization might grow in terms of its energy consumption. And so you can think about, Earth as a planet orbiting the sun. You've got sunlight hitting the Earth. And so if you imagine that our energy use is equivalent to the amount of energy we receive from the sun, then he called that a type 1 civilization. This is, we could call it now a Kardashev type 1 civilization. You're using all the sunlight or energy equivalent from the sun, starlight falling on your planet. Now, if you expand this scale and you were to utilize all the energy coming from the sun, say not just hitting the Earth, but everywhere in all directions, you build something like a Dyson sphere or a Dyson swarm. Just imagine a bunch of giant solar collectors all around the star at some distance, collecting as much starlight as you possibly can. He called that a type 2 civilization. So you're not just getting all the energy that's hitting your planet, it's all the energy coming out of your star. And then a type 3 is if you expand that to the whole galaxy, and you're a civilization that has spanned across the whole galaxy, and you're utilizing as much energy as the whole galaxy puts out from all of its stars. And so those are three scales that you can think about, in terms of the energy being used by civilization, and then also there's a spatial scale connected with that planet, star, galaxy. And some SETI searches have focused on specifically, like let's look for type 2 and type 3 civilizations in other galaxies, because if a civilization has spread across a whole galaxy and is technologically active, that might be more detectable than a more juvenile technological civilization next door to us. And so that's a valid hypothesis, and there's been some searches that have been done for that. But so this is Kardashev's idea, is to think about these exponentially expanding civilizations, and then that's kind of where we come in and say, like, maybe not all projections of the futures are really going to have this continuous exponential growth.
Yeah, so we are. I just asked my best friend an AI. I'm not gonna say which brand, but I have an AI that's always ask my question. So this AI told me that we are Kardashev 0.72 at the moment, to give our viewers an idea. So we have not yet mastered capable of collecting all the energy that our planet receives from the sun.
That's right. Yeah, sounds about right.
That's we are at this level. Okay, so how many of this in this scenario of the civilization you have how many of those civilizations are not growing then? You say there's 10 of them.
Right, there's 10 scenarios. We had 4 that are growing, only one of which reaches this Kardashev type 1 scale. So, it's not to say that what Kardashev envisions is not possible or not represented in our scenarios, but it's 1 out of 10. And there's 3 that have growth still, but at a much slower rate. Kardashev assumed a rate of 1% growth in energy per year, and so ours is right on 1%, the one that hits that Kardashev type 1 threshold. The others are much less than even around 0.5% or less for some, which is encouraging to think about, because again, we like to, our imaginations can run wild thinking about, like, oh, there's a lot of problems today and we don't like these trajectories, and you draw a straight line and it leads to catastrophe. But we show already, okay, here's 3 scenarios that still have growth, but it's much slower growth than if you look at recent history, and so that's already encouraging. Then there's 3 scenarios that stabilize. There's a little bit of growth, but then you just reach a stable equilibrium, which is what we would all love to find, is you solve some of these major problems, and then energy use and population growth equilibrate, and you find a way to live in balance with the Earth systems, which would be great. And then we have a couple collapse scenarios, and then even one that oscillates. It kind of grows and collapses, and then you kind of at a collapse stage, and then grows and collapses again. There was a Chinese graduate student who saw me give a talk about this, and he came up to me afterwards and said that Chinese dynasties have followed a pattern like that of about a 200-year oscillation, and so there's even historical precedent for that sort of thing.
That's the reason in the three-body problem, the alien civilization is also going through this growth and collapse regularly, because that's something that apparently the Chinese are familiar in terms of the history of growth and collapse.
Yeah, that's right. So, that was an interesting result. We didn't really go into it expecting to get one like that. It's certainly one of the weirder ones. That's S8, Ouroboros, which is the snake eating its tail. That's a bizarre feature. One that I definitely would not have been able to have thought of without sort of the use of this methodological approach.
All right. So let's talk about SETI. Most SETI research is based on the fact that civilization grow, technologically speaking, become noisy, radio, spacecraft, whatever, lasers, anything, even coming here. It's not really SETI, but I'm saying you and me agree that this is SETI. We're not going to enter into this debate. But so in this scenario that you have, you're showing that in fact, we may have civilizations that are not detectable using our current setting, because we assume technological development, right?
That's right. There's some really interesting outcomes. We think about different ways that you can do searches for technosignatures. SETI, there's the conventional radio SETI, but we've got the James Webb Space Telescope and some other future ones that can now look at exoplanets, look at their atmospheres, see if you can identify what gases are in there. And so we can start to think about looking for things like pollution in an exoplanet atmosphere, or city lights, or things like that might indicate technology. But there's three of our scenarios where if you were to do that, if you were to do either, I think, radio telescope, but especially if you were to do this, build a giant, habitable world observatory that they're planning and observe these planets at high resolution, figure out what's in their atmospheres, they would look the same as pre-agricultural Earth before any agriculture or civilization or technology, if you looked at the gases in the atmosphere. But those same scenarios have technology elsewhere in the system, all the way out to Pluto and the Kuiper Belt in some cases. So it's kind of an interesting example of some false positives, where you could find a planet that has a biosphere and say, oh, there's evidence of biology, but I don't see evidence of technology, so I'm going to assume that's a planet that just has simple life. And you'll have missed what SETI has been looking for, because this is a system that's actually teeming with technology. But if you look for it in a sort of narrow set of ways, that's what we're capable of doing right now, you're going to miss it. And so that's kind of one of the conclusions, is that here's a bunch of case studies based on trajectories from Earth that are at least plausible from what we know about physics and life in the universe. Some of these are going to be very challenging to find, and if some of those represent anything that might be out there, it behooves us to think more strategically about how would you find some of these things if our conventional searches are not going to be able to.
Is that another paper?
We are working on another paper to think about this. Yes, I mean the short punchline is the easiest way is to go visit. You don't have to send a person, but the spacecraft to do actual interstellar exploration is going to tell you a lot more than you'll ever be able to learn with a radio telescope or a optical telescope. But of course, it takes a long time to get there.
Yes. Okay, we're gonna take questions from our viewers. I'm sure these people have a lot of questions. Let's start now. In fact, we already have a few of them. No, I don't know which one. There is so many. We need to start. No? Okay, time comment. We need to start looking at cosmic events that we have historically attributed to natural events. Just imagine what a Type 3 civilization will be generated out there. I don't know what the question is, but can you comment on this statement?
Well, I think that is a good point. And so I'll mention that the second paper in the series, we kind of think a little bit, again, about the Kardashev scale, and just sort of decomposing how, like, okay, you can prioritize expanding in space, you can prioritize expanding your energy scale, you can kind of do trade-offs between these two. And so we think about, like, okay, what if you go beyond, what Kardashev thought, we were using sunlight? Well, what's beyond sunlight? What if you want to use more energy than the sun puts out from its photons? Well, you have to eat the star. You can consume the star's mass. There's more energy.
Mm-hmm.
It's out there for sure. But to think about how much more energy would there be? Orders of magnitude more by consuming the star's mass. It's E equals mc squared is the amount of energy you get out of the mass versus just the photons coming from the star's luminosity. And so to the question, I think is a good one here. This is not necessarily Type 3, but just thinking about natural events or natural phenomenon that might actually be more interesting in a technological sense. And so my colleague Clément Vidal, we collaborated on this paper where he looks at closely accreting binary stars. You have two stars that are orbiting each other. One might be a black hole or a neutron star. There's a bunch of, and we know about these, they exist, and you have matter flowing from one to the other. And so he just asked the question, like, well, what if some of those are actually technological systems, and it's a thing that has evolved in ways that are not really that similar to life on Earth today, but you could at least imagine there's a huge energy flow going from one star to another thing, maybe the other thing or the whole system. It's you could imagine a thing moving from star to star, feeding on stars at very large astronomical timescales. So I think that's an example of this. Like, not to say that all closely accreting binary stars are technological, but what would we have to look for? And maybe there's things that are right in front of us that we just have to recognize are technological, and we just haven't thought to think about it or look in the right way. So it's definitely worth keeping our minds open.
Thank you, Jacob. Yeah, we're reaching the end of our half hour. I don't want to take too much of your time, but I have a final question for you. So first of all, we have been exchanging emails for like more than 10 years now, from time to time. I already follow your research, and I really like reading about what you do and those new ideas that you're bringing up. So thank you for doing that for SETI, and it's a very remarkable. Your work has been very impactful for my research, for my personal research, and I talk a lot about your papers.
I appreciate it. Thank you. That's great to hear that.
So I have a question, like kind of personal and at the same time, but also interesting, I think, as a scientist. So when you look in the future in 1,000 years, for Earth, for SETI in general, are you optimistic? Are you concerned? What do you think? What should we do as a civilization to reach one of these future and one of the best future?
No, that's a great question to end on. The whole purpose of doing this is to prepare ourselves for the future, to challenge people to think more broadly about the future than we may otherwise do. And I think that is how we create the future that we want to live in. So I'm optimistic. I think humans have a lot of great qualities. I think there's some global problems that we have to solve, obviously. I think we are up for it. I think we'll be able to withstand some of the consequences, even if we don't deal with all of those things perfectly. And I think having some optimism can help kind of navigate that transition. So yeah, I think we should be optimistic about the future. We can't be lazy, but we can be innovative, and we don't have to throw up our hands and just become nihilists.
That's a very good way of finishing this conversation. So thank you, Jacob, again for coming to our SETI Live, for sharing with us the result with this paper. I hope you're gonna come for the next 5 or 6 papers. You said there will be like a series of 4 or 5.
There's more. Yeah, I'm happy to come back and talk about them.
Take care. Consider that this is an open invitation. When the next paper is published, you come to tell us tell us about it as well.
Will do. All right.
With an audience, and people will probably be more and more interested in what you're doing. We have been posting on our social media the link that you mentioned from the Blue Marble Space Institute of Science, the future.bmsis.org, where they can read about those different 10 scenarios for the future of our Technosphere. And we also I've shared the article itself. It's open access, so everybody can read it. Thank you for doing this as well. And thank you again. And thank you to all our viewers for joining us. We've been talking about the future of our civilization and the impact for SETI. And if you want to support this kind of program, go to our website, seti.org. You can join our social media. We're on every platform that exists. You can comment this video, give us a thumb up, and join, I don't know, just subscribe, like they say, subscribe, so we can see, you can get more of those videos. We talk about astrobiology in general and SETI, of course, and we invite researchers every week to tell us about the newest paper. So you will be aware of what's going on in the field of astrobiology and SETI. And you can also go to our seti.org/give now to make a small donation to help our researcher to find life, maybe intelligent life, elsewhere in this galaxy. Thank you very much again, and see you next week. Bye-bye.